Today's lesson is on the sum and difference trigonometric identities. I'm not going to derive them for you. There is a derivation in your book if you'd like to take a look. I'm just going to use kind of a proof by contradiction. So let's say I have sine of 180. Okay, I can write that as sine of 90 plus 90. Now, way back when, you were introduced to implicit multiplication, and now your brains are trained to see parentheses like this, and you want to use the distributive property. So let's say your brain says, I'm going to distribute sine. Okay, sine of 180, the y value at 180 is 0. The sine of 90, however, is 1. Okay, so this and this are not equal because sine is not multiplication. So we can't use the distributive property. Okay, I'm going to write the sum and difference identities out for you, and I'm going to do it in two different ways. So I want you to wait until they're up here and then decide which one makes the most sense to you. Okay, the sine of A plus or minus B, so I'm going to combine the sum and difference in one here, is going to be sine A cosine B plus or minus the sine of B cosine of A. So notice we've got sine and cosine and then the angles switch here. This is one way to write it, or we can write them separate. So you can combine it plus, minus, or you can write them as separate plus, minus, minus. Cosine of A plus or minus B is going to be the cosine of A cosine of B minus plus sine of A, sine of B. Now this is written purposefully, and I'm guessing you can guess what this means, that if it's a plus on this side, it's a minus on this side. And if it's a minus on this side, it's a plus on this side. So I prefer the combined versions, but you can also write them separated out. So if you write it separated out, then you've got a plus here, minus here, plus here. Like I said, I like these because it feels like two identities rather than four, even though they really are technically four. Last one I'm going to write here is tangent. So there's tangent, but don't worry too much about tangent because in the most cases, if I've asked for tangent, I've already asked for sine and cosine. So we're going to add these identities to our list, our identity sheet. So either write the black ones here, or if you prefer, those blue ones. So you want to add these identities to your trig identity worksheet. So now we can use these in different situations. Okay, so we're going to find the exact value. Our first one is going to be cosine of 75. When you're asked to find the exact value of a trig function, that means we're going to want to use the unit circle. Well, 75 is not on the unit circle, but I can rewrite it as the sum of two unit circle angles, 30 and 45. Okay, now that I write it like this, I can apply the rule. So we apply the trig identity for cosine. This will be my A, this will be my B. So we're going to have cosine 30, cosine 45. If this is a plus for cosine, this is a minus. Sine 30, sine 45. Then we go to the unit circle and fill in these values. So the x value at 0 is root 3 over 2. Cosine 45 is root 2 over 2. Sine of 30 is 1/2. Sine of 45 is also root 2 over 2. So this is going to be root 6 over 4 minus root 2 over 4. We can't do anything about combining root 6 and root 2, so those just stay like that, all over 4. So the exact value, it's not super pretty, but the exact value of cosine 75 is root 6 minus root 2 over 4. Okay, we're going to do the same thing with sine 195. Now there are a lot of different correct things that you could add or subtract to get 195. Okay, I see 135 and 60. You could do 45 and 150. Those are all valid choices, and you'll get the same thing. So now we're going to apply the sum identity for sine. So that's going to be sine 135 cosine of 60 plus the sine of 60 times the cosine of 135. Okay, the sine of 135 is going to be root 2 over 2. The cosine of 60 is 1/2. Sine of 60 is root 3 over 2. Cosine of 135 is a negative root 2 over 2. So this is going to be root 2 over 4 minus root 6 over 4. So as you go through these, you're going to end up with a lot of answers that look pretty similar because we're still restricted to those unit circle values. So you'll end up getting the same thing. All right, cosine pi over 12. So this is going to be cosine of something over 12, and we're going to do minus. Pi over 12 is a small number. So I'm looking for two things that if I took their difference would be 1, but then if I reduced them would be unit circle values. So you could have like 2 and 1, but those aren't going to reduce. So the first one I think of is 4 and 3. Because 4 minus 3 gives me just that 1 pi, but 4 pi over 12 is equivalent to pi over 3. 3 pi over 12 is pi over 4. Now we're going to apply the cosine difference identity. So this is going to be cosine pi over 3, cosine pi over 4, plus sine pi over 3, sine pi over 4. Then we use our unit circle. 1/2 root 2 over 2 plus root 3 over 2 times root 2 over 2. So this is going to be root 2 plus root 6 all over 4. So now we're going to find the exact value of this odd expression. So what we need to do is decide which sum or difference identity we're looking at here. If we look at our formula sheet, if it's a cosine, then that's the identity for cosine. So this is going to be cosine of 7 pi over 8. If this is a plus, that means this is a minus. 5 pi over 24. Okay, so I'm going to get a common denominator here by multiplying this by 3. So this is going to be 21 pi over 8. So 21 minus 5 is going to give us 16. Then we reduce that. 8 goes into both of those, so we have 2 pi over 3. And then on our unit circle, cosine 2 pi over 3 is negative 1/2. So this one kind of looks like the last example, but we have x instead. So again, we want to look at which identity we're looking at here? Well, this is the expansion of sine, because it's sine, cosine, cosine. This will be sine of 2x. If this is a plus for sine, that will be a plus. So this is going to be sine of 7x. Okay, now we did verifying trig identities. Now we have new tools to use, so we're going to verify with different things. So what we're going to do, just like before, we pick the more complicated side, or the side we can do stuff with, which is going to be this one. Again, you're going to be tempted to distribute, but we do not do that. You need to use the difference identity for cosine to expand this. So this is going to be cosine pi over 2, cosine x. If this is a minus, this is a plus. Sine of pi over 2, sine of x. Using our unit circle, cosine of pi over 2 is 0. Sine of pi over 2 is 1. So 0 times cosine makes that go away. So we're left with 1 times sine, which is just sine of x, which is what we were trying to verify. Okay, we did solving trig equations. Again, we have a new tool, so we'll do solving equations with these identities. Okay, this one's going to get really big because we're going to have to expand this sum and this difference and then do the difference between them. So we'll do the cosine here. So cosine x, cosine pi. If this is plus, this is minus. Sine x, sine pi. Minus, and I'm going to put this whole thing in parentheses, we're going to use the difference identity for sine. So sine x cosine pi, if this is a minus, this is a minus. Sine pi cosine x. Okay, and that all equals 0. Okay, so I'm going to evaluate each of the things that have pi. So this is going to be cosine of x times the cosine of pi is -1, minus sine of x times sine of pi, which is 0, minus sine of x cosine of pi is still -1, and then minus makes this a plus. Sine of pi is 0 times the cosine of x. All of that equals 0. Okay, so this and this are going to go away. So I have a negative cosine x -1 times this minus will be plus sine of x. I'm going to go ahead and add the cosine over. Now this one, you could square it and solve it that way, or you just think about this logically, where between 0 and 2 pi is sine of x equal to cosine of x? Well, that'll be at the pi over 4s in the first quadrant and the third quadrant, because in the first quadrant they're both root 2 over 2, in the third quadrant they're both negative root 2 over 2. Okay, this one's going to be pretty similar. So again, this is going to get bigger before it gets smaller. So we're going to apply the sine sum identity and the sine difference identity. So we're going to have sine of x cosine pi over 4 plus sine of pi over 4 cosine x minus sine x cosine pi over 4. If this is a minus, this is a minus. Sine pi over 4 cosine of x equals 0. So all our pi over 4s are going to be root 2 over 2. So I'm going to have sine x times root 2 over 2 plus root 2 over 2 cosine of x minus, this is going to be sine x times root 2 over 2 minus root 2 over 2 cosine x. Okay, well this minus, I've got a sine x root 2 over 2 minus sine x root 2 over 2. So those are going to go away. And then we have root 2 over 2 cosine minus a negative. So we're going to be adding root 2 plus root 2 over 2 would be root 2 over, well, 2 root 2 over 2. Or just root 2. So cosine x equals 0. And between 0 and 2 pi, that's going to be at pi over 2 and 3 pi over 2. Okay, our last example, we're given several pieces of information. If sine of A is 4/5, A is an angle, is in quadrant 2. Sine of B is negative 5/13. Angle B is in quadrant 3. We're going to find the sine of A plus B, cosine of A plus B, tangent A plus B, and cosecant A plus B. Okay, so let's start with sine. I'm going to start by writing out the whole identity. I'm going to leave some room here because I'm going to have to do some work. So sine of A plus B is going to be sine A cosine B plus sine of B cosine A. Now if I look at this identity, I have sine of A, I have sine of B, I do not have cosine of B or cosine of A, but I can use triangles to find these. So I'm going to draw a triangle for A, and I'm going to draw a triangle for B. I don't know what they are, they're just angles. If sine of A is 4/5, that means the opposite side is 4, the hypotenuse is 5, which makes the adjacent side 3. So in this triangle, cosine is going to be the adjacent. So cosine of angle A is going to be the adjacent over the hypotenuse, so that's 3/5. But we're in quadrant 2, so this is going to be negative 5/13. So opposite over hypotenuse. Okay, doing the Pythagorean theorem, you're going to find that this side is 12. So cosine of B, B is in quadrant 3, so this is a negative 12/13. So now I can substitute in my specific values. Sine of A is equal to 4/5. Cosine of B is equal to negative 12/13. Sine of B, we were given, is negative 5/13. Cosine of A is going to be a negative 3/5. So then this is what we're simplifying. So we're going to have a negative 48/65. Minus minus makes this a plus 15/65. So when I add those two things together, I get a negative 33/65. Now we're going to find cosine of A plus B. Using the identity first, cosine A, cosine B, minus, if this is a plus, sine of A, sine of B, and then just plug in the correct things. So we're going to have a negative 3/5 times a negative 12/13. Sine of A is 4/5. Sine of B is negative 5/13. So this is going to be a positive 36/65. Minus minus makes this a plus 20/65, which is 56/65. So we found sine of a plus b is negative 33/65, and cosine of a plus b is 56/65. We're going to use those to find the last two, tangent and cosecant. Tangent is just going to be sine over cosine. So it's going to be the sine of a plus b over the cosine of a plus b. That's going to be negative 33/65 over 56/65. Well, we have the same denominator here, so this is going to be negative 33 over that 56. Last is cosecant. Well, that's just going to be 1 over sine of whatever a plus b is. So that's going to be the reciprocal of this, so negative 65 over 33. So one last question. I want you to think about what quadrant a plus b is. A is just an angle. B is just an angle. We're adding those two up, it's another angle. Well, if the sine is negative and the cosine is positive, sine is negative, so we're below the x-axis, and cosine is positive. So this one would end up being in quadrant 4. So that is sum and difference identities.